Alright, so this video covers the 2015 number 3 question. It's the sparse array question. Now, this is probably the hardest question I've ever seen on an AP test, and it messed with the curve. Like, the whole nation did bad on it, so it messed with the curve really bad. So, um, it's a good array list problem to kind of think through, but I wouldn't expect something this difficult. And if you do get it, then you can expect a high curve on this. So let's go through it. It says a two-dimensional array of integers in which most elements are 0 is called a sparse array. Because most elements have a value of 0, memory can be saved by storing only the non-zero values along with their row and column indexes. The following complete sparse array entry class is used to represent non-zero elements in a sparse array. A sparse array entry object cannot be modified after it has been constructed. All right, so again, the sparse array has basically most of the elements are 0, but some of the elements have a number in them. Okay, and so instead of creating now, this is what gets people screwed up in this, is that the images are of a 2D array when really we're the whole time working with just an array list. Now, instead of creating a 2D array with all the zeros in here with just a few sporadic entries, what they're saying is that they can save space by creating an array list that looks something like this, where you have entries as your array list, and you've got array list index 0, 1, 2, 3, and there's a row and a column. Now, if we were to store this in a two-dimensional array, this is where the information would be stored in the two-dimensional array. So row 1, column 4, the value is 4. Row 2, column 0, the value is 1, and so on and so forth. So you're really, again, working with an array list, and I like how they drew this out, because entries would be at index 0, 1, 2, 3, and this is what entries knows. It knows a row, a column, and a value. But pictures tend to be, more powerful than words and make more sense to kids. So I think what happened is that kids got stuck in this idea that we're working with a 2D array and not an array list. So if you just get that out of your mind, I think that solves a lot of problems. All right, so here's your sparse array. Your sparse array object. It knows a row, a column, and values. You pass in a row, or an R, a C, and a V, and that gets stored in row, column, values. The sparse array knows how to get the row, get the column, and get the value. So that's just your object. So again, entries down here just has sparse array entry objects in them. So that's sparse array entry object, at element 0, and then 1, 2, 3, and so that's that right there. And then the sparse array, it represents a sparse array. It contains a list. So here's your list of sparse array entry objects, each of which represents one of the non-zero elements in the array. The entries representing the non-zero elements are stored in the list in no particular order. Each non-zero element is represented by exactly one entry in the list. So let's see here. You've got your entries. So when you construct your sparse array, you construct it with an entries array list of sparse array entry objects. And it can get the number of rows, get the number of columns, and we're going to get the value at. We'll pass in the row and column, and we will remove a column. So let's go down here. So the following table shows an example of a two-dimensional sparse array. Empty cells in the table indicate 0 values. The same array can be represented by a sparse array object sparse with the following information or instance variable values. The items and entries are in no particular order. One possible ordering is shown below. So write the sparse array method. Get value at. The method returns the value of the sparse array element at a given row and column in the sparse array. If the list entries contains an entry with a specified row and column, the value associated with the entry is returned. If there is no entry in entries corresponding to the specified row and column, 0 is returned. In the example above, the call 3, 1, so that's your row and column. It returns -9. So there's your row and there's your column. It returns -9. And the sparse get value at 3, 3. Is there one with row 3, column 3? Nope. It would return 0. So again, to get the right answer, don't look at this. This right here, 2D array, screws you up. All you're doing is going through each of these, sparse array element 0, sparse array element 1, sparse array element 2, the sparse array entry 3, and going, hey, is there anything at the row and column 3, 1? Yes, there is. So return -9, and if there's not, return 0. Okay. So writing this thing should be pretty easy if you get that 2D array stuff out of your head. So remember, row and column are passed in, so this is part A. So first thing we'll do is we'll return 0. And why will we return 0? Because if we don't find it, we have to return 0. So that's really easy, right? And so, now all we're doing is getting the value, right? Because doesn't our sparse array entry get the value? Yep. We get the row, we get the column. And so we've got to run through our sparse array entry, our sparse array entries, which are the entries right here, okay? So we're not working with an index position or whatever, so we don't want to do a normal for loop. We want to do a for each loop. So we do for, and we got to go through each index and entry. So sparse array entry, and I'm going to just say entry. And then entries. So this is our object right here. That's our object, our array list, right? It has a object type of sparse array entry, and for each single entry, that's going to be your placeholder. Okay, so we'll say if entry dot, and so our sparse array needs to get the row, so we get the row, if that is equal to the row that's passed in and the entry dot get the column is equal to the column that's passed in, then we return the entry dot get value. Okay, that will get the value of the row and column that we're in, and that's it. Again, the whole country did bad because I think they were stuck in this thing going, all right, I need to do a 2D array and go through each row and column and check to see, you know, like, no, stick with this, and that's all you're going to care about. And it even becomes more important in the next one because the next one is a nightmare, but it really doesn't need to be if you just think about it like this. Here's entry. Here's position 0, 1, 2, and 3, and it's got a row, a column, and a value, and that's all it has, and that's all it knows, okay? So anyway, part A is done. I mean, that's not too hard. All you do is you go through all the entry objects, get the row. Sorry, and I screwed up. It's not 3. I was thinking of the one of them. It needs to be row because that's what's passed in is row. So if we get the row and it's equal to row and you get the column and it's equal to the column, then we get the value. And we'll see if I got any other mistakes in there. I think it looks pretty good. Okay, so for part B, let's see what we got. Write the sparse array method, remove column. Again, when you think of removing column, you're thinking about removing a column because they got a picture of a 2D array. That screws up your head and thinking on how this thing works. And then they've got, you know, number of rows and number of columns and all that other stuff in here that kind of screws your thinking up as well. So it says write the sparse array method remove column after removing a specified column from the sparse array. All entries in the list entries with column index matching call are removed from the list. Okay, again, what's passed into this thing? The column is passed in. So all you're doing is going, you know, let's say they say, I guess, again, don't focus on this one up here, but they're saying, okay, remove the column if the column is equal to 1. Then we just remove these, and these two exist now. So that would be this first bullet point. If the column is equal to that, then you remove it. And then all entries in the list entries with the column index that are greater than column are replaced by the entries. So 0 is not greater than 1, so you don't do anything with it. And column is greater than, so column right here, 4 is greater than 1, so you want to shrink that down by 1, which creates some other issues that are hard to deal with. All entries in the list entries with column indexes greater than 0 are replaced by entries with column indexes that are decremented by 1. Move 1 column to the left. The number of columns in the sparse array is adjusted to be reflected. Okay, so this one is difficult because look at this. This removes or moves the column down by 1. It still has the same row and the same value, but what's hard about this is that this is an array list, so you actually have to rebuild this thing, okay? And in these two cases, you actually just remove them. So now you have to deal with the, you know, the dot set and dot remove methods of your array list, okay? So let's think about this. Now, if you do that, you also have to know what index position you're in, which makes it a little bit more difficult too, because yeah, let's just kind of go through this. So because you need to know what index position you're in, you can't use a for each loop, but you also don't want to use a for loop, because a for loop will automatically, remember, we're going to remove entries, right? So you have to be able to program so that if you remove the first one, or wherever you're, like, let's say we would, this isn't the case, but let's say we had to remove where the column was 4. That would be in index position 0. And then everything would get shifted down one. So now this would be index position 0, this would be index position 1, and this would be index position 2. But in a for loop, at the end of the for loop, you add I to it. So then this would be index position 0, but my I would be 1. So it would skip over it. So you want to use a while loop here, okay? And so if you're going to remove information from an array list, you might need to use, and I'm saying, this is just good strategy, you might have to use a while loop, because again, that for loop is always going to add 1 to it. Now, if you decide to use a for loop, you're going to have to subtract I from somewhere so it doesn't skip over this first position, okay? So this is how I would do this. I would say we've got int I equals 0. That's our index position. We'll have our while loop. Okay. And does it say, let me see here. The number of columns in the sparse array is adjusted to reflect the columns removed. So, number of columns is 5. We remove 1. Now we got to have number of columns being 4 now. So that's something that's easy that we can type out. So at the very end of this thing, after we're all done with our while loop, we could say num calls minus minus, okay? Now back to the hard part. We'll say I is less than our entries dot size. So in this, we'll have a sparse array entry, and we'll call it entry, equals the entries dot get, what's that position I, okay? So we get what's at position 0, which, position 0 is going to be this entry right here. And we got to check to see, does the column equal the column that's passed in? And so in this example, it's 1. But let's say our column was 4, then we would need to remove it, okay? So if column that gets passed in right here, if that is equal to this right here, then we've got to remove it, okay? So if our entry dot get call is equal to the call that was passed in, then we entry dot remove what's that position I. All right. So if this case, if column was 4 in our first, so we get what's at I, which would be 0. So this is at position 0. And again, I don't even like looking at that thing. This is the best thing to look at. If we're right here in index position 0, if our column's equal to the call that was passed in, so is 4 equal to 4, yes, then we remove this. When we remove this entry, everything again gets shifted down to the left 1. So this is our new index position 0. Okay? Because of that, we do not want to do I++ anywhere. So then it would go back up into our loop, and now we're at index position 0 still, and we would get what's at index position 0, which would be this right here, and is 4 equal to 0? No, it's not. So we would have to figure out what to do with this, okay? And this one, okay? Now, let's go back to this example where we want to remove anything with column 1 in it, okay? Any entry with where the column is equal to 1. So we built this first one. Now we got to build the next one. Actually, no, we don't. Well, let's say, yeah, shoot. Just a second. I'm gonna sneeze. All right, so let's go back here and let's assume that our column is position or is 1, and it removes these 2 by this code right here. Again, we're assuming that, let's say this is 1 right here, all right? It would remove those because we have this code right here. We get the column where 1 is equal to 1, and it would remove it. Okay? Now, what do you do with these ones, okay? Because I think we got the first bullet point correct. All entries in the list entries with the column index column are removed, okay? So what do we do with, if our column that's passed in is 1, what do we do with this one where our column is 4? That's where bullet point 2 comes in. All entries in the list entries with column indexes greater than the call are replaced by the entries with the column indexes that are decremented by 1. Moved 1 column to the left. All right, so this is the hardest part of this whole thing. So we would say else if entry dot get call, if that is greater than the column that was passed in, now all we're doing is we have to subtract our column inside that by 1, but in order to do that we have to use the set method. So in order to do that we have to say entries dot set I, we're setting what's at position I to a new sparse array entry, and the new sparse array has an entry dot get row, entry dot get column -1, and entry dot get value. This right here is likely what threw everyone through a loop, okay? You can't just subtract get call -1, entry dot get call -1. You're actually rebuilding this entry, and so in order to do that you have to set what's at position I. In this case it would be right here what's at I. You have to reset that to everything in here, which is entry -1. And then you do I++ to be able to then move on to this one, and then this one, and then this one. Okay. Now the third one, the number of columns in the sparse array is okay. So what if your column is less than the column that they pass in? So this one's 0, and what was passed in was 1. Then you just ignore it and move on to the next one. So all you do is just that you got a hanging else statement right here. So that's where you just do I++. Again, between, most people don't use while loops. They use either for loops, or then they think about these as for each loops. And right here with remove and not doing an I++, because remember everything gets shift over to the left, and then this line of code right here, part B through the entire nation through a loop. And so this one is a very difficult problem. But this is the code for it. Let's see here. I got the example. So here's the answer, and I already got that. I don't know. They use E. I like using the word entry as like a single one instead of just creating the word E. But let's see here. Part A, access all elements. So that's where you need your for each loop. No out of bounds. Identify elements of entries at the row and the column and the column index call. So this is where you would do what? Right here, get row and compare it to the row, and get the call and compare it to the call. And then return identified value, or return 0 if no entries. So you got to get the value or it returns 0. So if we find it, then we return get value of the entry, else you return 0. So that's the final point. Now for this next one, you need to decrement the columns exactly once. So that's easy right there. That gives you a point. So anyway, this whole thing to me, A is easy. That should be 3 points. And then that should be a point right there. So that'd be 4 points out of 9. It sounds bad, but it's really not. Access all elements of entry. No out of bounds. So that's right there. That's a point. That's not hard to do either right there. You guys can all write that code out. That'd be 5 points. If you guys got 5 points out of this, you would be doing great, especially with the difficulty level of this. Okay. So identify and removes the entry with the column at the specific index. So that's this right here. You remove it. Process entries with columns greater than the column within the loop. Creates a new sparse array entry with the current row index column index -1. So that's this line of code. Identifies and replaces entry with a column index greater than 0 with the created entry. Creates new. I don't know. This seems like the exact same line of code, right? Process entries, creates a new one, identifies and replaces entry with the column with the created entry. I don't know. These points to me seem like the same line. I don't know, maybe students were putting like .add or something in there, and they weren't, which would, if you did a .add, it would create a new sparse array entry. But then if you did .add, it wouldn't replace it. So I'm not really sure. To me, both of these points are this line of code right here that they're giving 2 points to, and I'm just wondering if students did like a dot add and then something else where they actually didn't replace the old entry. I'm not sure. Last one on exit, all and only entries with column index call have been removed, and all are only all entries with have been changed. So minor loop errors, okay. So again, you got to get kind of the right answer to get this one. So I don't know. To me, 6 of these points are easy, and the last 3 are really kind of. I mean, you really have to know your stuff to get those last 3 points. But again, 6 out of 9, you know, with how we do in multiple choice. You know, that's going to get you out of 4 or 5 in this class still, because again, this is probably the hardest AP written problem I have seen, and so I don't think all of them are going to be this difficult, so I think you'll be fine. So anyway, this video's done.